Hello students, welcome to my YouTube channel. In this lecture, we are going to solve questions from Keith Williams' VOR chapter. So we are going to solve questions starting from question 91 to question 100. Okay, so we will be making a century in this video. So let's start with question 91 for today. Maximum theoretical range at which aircraft at flight level 230 can receive signals from a facility sited at mean sea level is what? So very simple question. Use the formula for range, which is 1.23 into h1 plus h2. Substitute the values 1.23 in place of h1. Put height of aircraft, which is 23,000. The vertical distance of the station is 0 since it is at mean sea level. So 1.23 into square root of 23,000 is equal to how much? So 1 point square root of 23,000 is 151 decimal 6. So 1.23 into 151 decimal 6, 186.5 nautical miles. So the closest option here is option A, 190 nautical miles. Okay. So let's go to question number 92. The VOR system is limited to about 1 degree accuracy. 1 degree at 200 nautical mile range represents a width of how much? So here is a VOR station. This is the radial of that station and it is limited to about 1 degree of accuracy either side. So this is the erroneous radial or wrong radial which will be accurate, which will be separated by 1 degree. And now you have to calculate the width. This width, your aircraft is 200 nautical miles away from the VOR station. Okay. Aircraft may be correctly established on this radial, or if it has gotten a wrong radial and followed that radial, it will find itself somewhere here instead of being correctly established on this radial and to be situated here. So we have to find the width between the correct position and the wrong position. Using 1 in 60 rule formula. Let's use that. Track error is equal to distance off track divided by distance gone into 60. So track error is 1 degree. Distance off track we have to find out. Distance gone is 200 into 60. So distance off track is 200 divided by 60, which is equal to 3.3. 3.3 nautical miles. You can use tan theta formula also. Tan theta is opposite side upon adjacent side, which is equal to width, in this case divided by distance that you have traveled. So tan 1 is width divided by 200. So width is equal to 200 into tan of 1 is equal to 200 into 0.017. Okay, so multiply that by 200, you get a value of 3.5 nautical miles. Okay, so with 1 in 60 you get 3.3. With tan theta formula you get 3.5. So select the correct option is Bravo, 3.5 nautical miles. Question 93. Aircraft is situated at 30 degree north, 5 degree east. VOR is at 30° north, 13° east, and variation at both places are given to you. What what is the radial of what is the radial on which your aircraft is situated? So let's draw the diagram. VOR is at 30° north, 13 east. Aircraft is at same 30° north but 5° east. 5° east. So that means if this is your north direction, okay, so your aircraft is to the west of the VOR. Aircraft is to the west of VOR. So the radial of this aircraft will be 270 true. That means your aircraft is situated on a radial of 270 from this VOR. But all VOR radials are magnetic in direction. Convert this 270 true into magnetic. So apply variation. Variation at VOR station is 15° west. In case of VOR questions, use variation at the VOR station. In case of NDV questions, use VOR at aircraft location. So 15° west. So radial will be 270 plus 15, which is 285. Variation west, magnetic will be best, meaning magnetic will be more than true. So you have to add it and you get 285. So the radial of aircraft is 285. Option Charlie. Okay. 285 radial. The closest is option Charlie. Maybe there is some printing error. Okay. Let's go to question 94 now. An airplane flies over a position which is due north of a VOR, which is at position D. So that means aeroplane is to the north of a VOR. So let's draw that. Here is your VOR station. An aircraft is at a position which is due north of VOR. That means exactly to the north of VOR station. Magnetic variation at aircraft is 18 west. Magnetic variation at VOR is 10° west. What is the radial on which aircraft is situated? Very simple. Aircraft is exact north of this VOR station. So the radial will be 360 true or 000 true. Now you have to apply variation which is at VOR station. So at VOR station the variation is 10° west, right? So variation west, magnetic will be best. What you do is 000 plus 10, which is 010 magnetic. That means aircraft is situated on a radial of 010 from the VOR. All radials are magnetic in direction. So option A is the correct option. Question 95. Under which of the following circumstances does a VOR DME area nav system will switch to dead reckoning mode? Now what is dead reckoning mode? Dead reckoning mode is nothing but deduced reckoning. Dead is the short form of deduced reckoning. So this is a method of navigation in which we estimate a position using indicated airspeed, wind velocity, time, heading of your aircraft. Okay, and combining these elements in your CX3, you will come to know when you are expected to reach your next significant point or any next point. Okay, so whenever you now if you have flown during a CPL training, or if you are yet to fly, we always do a cross country planning before we go on to a cross country flight. In that cross country planner, in that in that on that paper we fill all the information. Okay, if we are going to fly from point A to point B, a total distance of 100 nautical miles, we divide that total distance in small segments of 5 nautical mile each, 10 nautical mile each, depends. And then on the ground we take the indicated airspeed of aircraft, the cruising speed, and we know the distance to the next point, right? We know the forecast winds on that day during our flight time. And combining these elements, we come to know what will be our ground speed. And using that ground speed, in what time you will reach the next point. Okay. So this is how you make the cross-country flight plan, point to point. And then you come to know what will be the total time duration from point A to point B, what will be the ground speed, what will be the heading of your aircraft if you have to correct for wind drifts, right? But when you go in the air, when you actually start your aeroplane and take off, you start comparing or you start monitoring the conditions. If on the ground, let's say after takeoff, you are expected to reach the next point in 10 minutes. When you actually take off and you are taking 15 minutes to reach the next point, that means there is some calculation error in your calculation, or your calculation is right, but headwind, you are taking more time. That means maybe after takeoff, the headwind component has increased in magnitude, and therefore the speed of your aircraft has decreased, ground speed, and you have taken extra 5 minutes to reach the next point, okay, which you estimated to reach in 10 minutes. You have taken 15 minutes. So this is called dead reckoning. As you fly, you keep making the corrections because the forecast winds which you use during your ground preparation are not always the same as the actual winds. Actual winds will differ from your forecast winds, right? So you have to keep on updating the values, the time values, the speeds. You have to keep monitoring the situation and keep updating your cross country plan. This is called dead reckoning, navigation by dead reckoning. Okay. Now area navigation, opposed to that, is RNAV. In this, you estimate your position using VOR and DME. Now let's say this is your VOR station and this is the radial of that VOR station, radial 090. If I say your aircraft is on radial 090, it may mean that your aircraft is very close to the VOR on radial 090, far away from VOR, in the center of this radial, anywhere. So if your aircraft is on radial 090, we do not know with certainty whether your aircraft is far away from the VOR station or close to the VOR station. To resolve this ambiguity or to get more clarity, we also make use of a DME station. Now with DME station, we will come to know the distance from the distance, that is how far we are from a particular station. So we use a combination of VOR DME station. So with VOR we come to know the radial we are situated on, and with the DME we come to know the distance we are from that station. So if I say I am on radial 090 at a distance of 20 nautical miles. So with this I can plot an accurate position. Radial 090, radial 090, which is this in front of you, and a distance of 20 nautical mile from the station. So this is your accurate position. Okay, so area navigation is more accurate than dead reckoning navigation. And you need these two elements, VOR and DME. Now, either of this fails or either of this is not giving you that accurate indication, your system will automatically switch to dead reckoning. Okay, so the correct option will be VOR DME area navigation computer is receiving neither radial nor distance data information from the VOR DME station. Option B is correct. You are receiving neither the radial information nor the DME information. And the second option will be if you are receiving only one of them. Even in that case, the system will revert to dead reckoning mode. Okay, so remember this. Question 96. The identification of a DME in combination with a co-located VOR. Now, when a VOR and DME station are co-located, they will share the Morse code identifier. And this Morse code identifier is transmitted every 30 seconds. For the first, for every 30 seconds, 4 times. Okay, this Morse code identifier you will hear for 30 seconds. Okay, out of this 30 seconds, the first three times you will hear the Morse code of VOR, and the last time, that is the fourth time, you will hear the Morse code of a DME station, and that Morse code will be at a tone, which at a high pitch. This is how you distinguish between VOR Morse code identifier and a DME Morse code identifier. Okay, both. So when VOR and DME stations are co-located, for the first three times you will hear the code of VOR, and for the last towards the end of that identification, you will hear the code of DME. Okay, and at a high pitch tone. So VOR Morse code is you will hear for three times back to back, and for the last time only one time you will hear the Morse code identifier of a DME station at a higher pitch tone. Okay, so this is how you differentiate. So the correct option will be option alpha. In a period of 40 seconds, the DME ident will be heard once on an audio frequency of 1150 Hz. The VOR ident and the DME ident are the same. That is wrong. The DME ident will be repeated three times. That is wrong. It will be repeated one time. VOR will be repeated three times. Every 30 seconds, the DME ident will be repeated. This is not proper. This is not clear definition. So option A is the correct. Now here it's given 40 seconds, but real value is 30 seconds. So, but select option A. In some exams, they give 40 seconds. In some other exams, they give 30 seconds. So this is the answer, and this is the explanation. So remember that. Two aircraft are located on some arbitrary different radials but at equal distances from a VOR station. Which statement is true? So let's say this is your VOR station, and these are the two radials of that VOR station. This is the fixed reference signal of that VOR station. So VOR station transmits two signals. One is the reference signal, which is frequency modulated. Okay, it is fixed in direction, which is magnetic north. The other signal is a variable signal which rotates around the VOR, and it is amplitude modulated. Okay, so let's say this is one variable signal. At one moment of time, this variable signal has rotated and has come in this direction, pointing in this direction. So over here, the phase difference between, or the angular separation between the frequency modulated wave and this variable and this amplitude modulated variable wave is, let's say, 30 degree, is 30 degree. That means we will call this, or we will label this radial as radial 030. Now when this variable signal continues its rotation and comes in this direction, somewhat in this direction, so this is amplitude modulated variable wave. It comes in that direction, the phase difference between the reference wave and the variable wave will be, let's say, 50 degree. So we will label this direction radial as radial 050. Now in the question is given the two aircraft are situated on two different radials correction. So radial 030 and radial 050 both are at same distance away from the VOR. Okay. Okay, so now if they are both on different radials, that means that means the phase difference for this aircraft, radial 030 will be 30 degree. For this aircraft, the phase difference will be 50 degree, hence radial 050. So let's read the options. At a certain moment of time, the phase of the reference signal is equal and the phase of the variable signal is equal for both. Can it be equal? No. Since they are located on different radials, For this aircraft, the phase difference is 30 degrees between the reference wave and the variable wave. But for this aircraft, the angle between the reference and variable wave is 50 degrees. Okay, so it's not the same for both of them. At a certain moment of time, both the phase of the reference signal and variable signals are equal for both. Wrong. At a certain moment of time, phase of the reference signal and the variable signal are unequal for both aircraft. At a certain moment of time, the phase of the reference signal is equal and the phase of the variable signal is unequal for both. So the correct option will be option delta. For both this aircraft, this reference signal is going to remain constant, the same, 0 degree. What will differ will be this variable wave. For this aircraft, the variable wave is at 30 degree. For this aircraft, the variable wave is at 50 degree. So reference wave is the same with respect to both aircraft, but variable wave is what is rotating or is changing. So option D is correct. Phase of the reference signal is equal, but phases of the variable signals are unequal. Now question number 98, similar. Here they have told you that both aircraft are on the same radial, but at different distances. So let's take a VOR station. This is the reference phase signal. This signal is frequency modulated and it is going to remain constant, oriented in magnetic north direction, constant. There is another signal which is rotary, that is called variable signal. It will rotate around the VOR. Okay, so variable signal, and it is amplitude. It is amplitude modulated. Now the phase difference. Now the phase difference between the reference signal and this variable signal is 90 degrees. That means this radial will be labeled radial 090, and both aircraft are situated on the same radial. Only that one aircraft is closer to the VOR than other aircraft. Okay, so let's check the options. At a certain moment of time, the phase of the reference signals is equal and the phases of the variable signals is unequal. So this is wrong. Reference wave is going to remain the same for both aircraft, constant. Variable signal will also remain the same because both aircraft is on radial, both aircraft are on radial 090. Okay, so variable phase, that the phase difference of 90 degrees is going to remain the same for both aircraft. So A is wrong. B states that at a certain moment of time, the phase of the reference signal is equal and the phase of variable signal is equal for both. So option B is the correct option. Okay, reference signal is the same. Variable phase signal is also the same. Charlie, at a certain moment of time, both reference signal and variable signals are equal for both aircraft. This is wrong. This should be unequal. That is wrong. And the delta will also be wrong. That a certain moment of time, both the phase are equal for both aircraft. So there is some printing error, but option B will be the correct. Or you have to select that option which states that the phase of the reference signal as well as the phase of the variable signal are going to remain the same for both aircraft. Okay, so this is the concept. Remember this. Question 99. Aircraft is on a magnetic heading of 290 and is on a radial of 280. Which value has to be selected on the OBS to get a 2 indication and the CDI needle in the center? So this is your VOR. Aircraft is on radial 280. Now in case of OBS sums, the heading is irrelevant. In case of HSI sums, the heading is relevant. Okay, but still we will draw the heading of aircraft, which is 090. Section 290. Now if we have, now there are two possible options. Reciprocal of radial 280 is radial 100. Now this diagram is not accurate because radial 280 should not be here, it should be somewhere here. Ignore that. So if there are two possible OBS settings, first one being on radial 280, if we choose to fly outbound, we have to put 280 in the OBS selection. As a result, we will get a from indication. Okay. Being on radial 280, you can also choose to fly inbound towards the VOR. Okay. So in that case you will put OBS setting of 100 so as to get a 2 indication. So in the question they ask you what value has to be selected on the OBS to get a 2 indication. So you have to select a value of 100. Okay, very simple. Next, last question for the day. Aircraft position is on 34 degree 15 minutes north and VOR is at 3612 north. That means VOR is to the north of your aircraft. VOR is to the north of your aircraft. Let's say for the purpose of this sum, I'm taking this to be your northerly direction. So VOR is here and aircraft is to the south of the VOR. That means aircraft is on radial what? Is on radial 180. True. But all radials are magnetic. So apply variation at VOR station, which is 13 degree east. So radial will be 180 minus 13. Variation east, magnetic least, which will be 167 degrees. So option B will be the correct option. Now here they have also asked you, in order to read the most accurate ground speed from his present position, pilot must fly on which radial? Now in order to get ground speeds, in order to get ground speed, let's say this is your DME station, aircraft must fly either towards the DME station or away from the DME station. Okay, in these two scenarios, flying towards the station or away from it, you will get accurate ground speeds. If you are flying perpendicular to the DME station like this, the ground speed will not be accurate. Okay, so what happens when you fly towards the station or away from the station? You will be getting distance information, right? You are 100 miles from DME, 90 miles, 50 miles. Then the transponder, okay, the DME station on the ground, distance measuring equipment, and the your aircraft airborne equipment. It will keep on sending signals, your pulses, radio pulses towards the transponder on the ground, and this pulses will go and come back towards your aircraft. Okay, so this is called secondary mode of transmission is secondary surveillance or secondary radar principle. Okay, so the time it takes for the signal to go and come back will be registered here. The distance you are away from the station, once you know your distance and time, you can calculate speed, which is distance divided by time, and that is how you come to know the speed of your aircraft ground speed, by knowing the distance you are away from the station and by calculating the time it takes for the pulses to go and come back. So this is done automatically by the equipment itself, and you directly get the indications of distance and ground speed. But the only thing you have to take care of is you have to be flying directly towards the station or directly away from the station. Any other direction you are with respect to the station, you will be getting inaccurate ground speed readings. Okay, so the option will be option Bravo. Okay, directly airplane directly flying towards the VOR station or directly away from the VOR station. and that radial will be radial 167, which will take aircraft to the VOR or away from the VOR station. Now in this case, VOR and DME are co-located. Okay, so remember that. So with this, we have come to the end of this lecture. I hope you have understood all the 10 questions we have done today. If you have any questions or any queries, let me know. So, and I also suggest that you read VOR DME chapter. You read all the theory properly, mark the important points, make notes, and then come back to solving the questions. This will reinforce your concepts and also instill confidence in you. More you revise the theory, more your brain will work, and just looking at the question at the sum, you will come to know the answer by just looking at the options. Many a times you don't even have to solve the full solution. Okay, just by looking at the question and possible options, your mind will be able to estimate the correct option. That comes with practice. So keep practicing from different resources. I have solved questions from Keith Williams in the previous video lectures, Oxford as well, and RK Bali. So all the best. Do share this video with all your friends and subscribe to this channel if you haven't. See you in the next video.